Hello. Okay, so starting with question number 1, we got to solve the equation. It's negative 8 times t minus 4 plus 7 equals 4. Put a bracket, that's basically going to act as like another parentheses. T minus 3, parentheses, t minus 1 minus t, and parentheses, and the bracket plus 6. So the first thing I'm going to do is I'm going to kind of work inside out. So I'm going to first start with this bracket. The first thing I'm going to do, okay, actually first I'm going to rewrite it over here so I actually have space to work. T minus 4 plus 7 equals 4, bracket, t minus 3, 1 minus t, plus 6. Okay, first thing I'm going to do is I'm going to distribute this minus 3 into this inner parentheses. You should note that when we distribute it, both the 3 and the minus sign out front is going to get distributed. So it's going to be minus 3 times 1, which is negative 3. And minus 3 times negative t, which can become plus 3t. And then we have plus 6 equals minus 8, t minus 4 plus 7. Okay. Now I'm going to go ahead and I will combine the like terms inside this bracket. So we'll get, just writing everything down again. Inside the bracket, we have a t plus 3t, so that means we have, I'll say 4t. So the minus 3 plus 6 on the outside. Now I'm going to start distributing the stuff on the outside of the bracket and parentheses. So this minus 8 gets distributed, so it gets minus 8t. Minus 8 times minus 4 plus 32. It's always important to be careful with that. A common mistake that we see is students will forget the minus times the minus. They'll only distribute the minus onto one of them. Over here, we're going to get 4 times 4t, we'll get 16t. 4 times negative 3 is going to be minus 12 plus 6. I'll go and combine like terms on each side. So minus 8t plus 39 is going to equal 16t minus 6. Now I'm going to bring this 8t over. So 39 equals 24t minus 6. Bring the 6 over. So 45 equals 24t. So that means that t is going to equal 45 divided by 24. Both top and bottom of the fraction are divisible by 3. 45 over 3 is 15. 24 over 3 is 8. So our answer here is that t equals 15 over 8. For question 2, we're told to identify the following equations as either conditional, identity, or contradiction. Just to kind of like establish what each of these mean, conditionals we're going to x equals some number, where the equation will only work when x is equal to that number. Identity, you'll usually get at the end, like 2 equals 2, or 1 equals 1, or 0 equals 0. Something that's just like a true fact. And when that happens, your answer is going to be like all real numbers in terms of x. Like any x that you want to plug in will work. In contradictions, when you get something like 1 equals 5 or 0 equals 2, something that's not true, in which case none of the x's you plug in like will work because like, the equation just it's not a true equation because you're getting this weird contradiction. So let's go in, we'll simplify this. We don't actually have to solve these for x. I mean, we're going to try, but we'll see at the end whether it's a conditional, identity, or contradiction. But we don't have to technically write out the x solutions. We just got to label each of these. So first thing I'm going to do is I'm going to distribute the minus 8. Make sure you bring the minus with it. So 2x plus 16 equals 10x minus 8x. Minus 2 times minus 8 is plus 16. Combine like terms. We'll get 2x plus 16 equals 2x plus 16. Subtract 2x from both sides, we'll get 16 equals 16. That's true. So that means that this is, I'll put this in green, I guess, to make it more obvious, identity. Okay, now for this next one. I'm going to go in and I'll distribute this 4 inside this parenthesis first. So we'll get 3x minus 5 plus 4 equals minus 2, bracket, 3 plus 4 times 2 is going to be 8x. 4 times 5 is plus 20. I'll combine like terms inside the bracket. So I'm going to draw a line and separate the questions. Oh, that's the eraser. 3x minus 5 plus 4 equals minus 2. And then inside this bracket, 3 plus 20 is going to be 23. So say 8x plus 23. Okay, and now I'll distribute the minus 2, and I'll distribute the 3. So we get 3x minus 15 plus 4 equals minus 16x minus 46. So going from here, I'll combine like terms on this side over here. 3x minus 11 equals minus 16x minus 46. I'll add the 16x over here, so we'll get 19x minus 11 equals negative 46, my bad. Add 11 to both sides, 19x equals minus 35. And we can divide each side by 19, so x is negative 35 over 19. That doesn't reduce, but from here, this equation works when we have x equal to this specific number. Oh my goodness, I just erased again. I need to stop pressing that on accident. But x only works when it equals that specific number. We got an x equals in a certain number. So that means that this is, I'll put it over here on the side because I kind of ran out of space over here. This one is conditional. Okay. Now for this last one, I'm going to go ahead and I'm going to switch colors because there's a lot of work over here. I'm going to go to black, and I'll kind of work this one over here. So we have x minus 5 plus 2, x minus 4 equals 3x plus 1 minus 5. So I'll go and distribute these. So we have x, oh my goodness, I keep hitting that eraser button. Okay, so we have x minus 5 plus 2x minus 8 equals 3x plus 3 minus 5. We're going to combine like terms, so we're going to get 3x minus 13 equals 3x minus 2. Now we'll go ahead and move the 3x's over, so we get minus 13, because minus 3x on that side cancels, equals minus 2. Well, that is a contradiction. That fact is not true. Negative 13, negative 2 are two different numbers, so we say that is a contradiction. Okay. Okay, I went ahead and erased all our previous work. Go on to number 3. We need to solve the following rational equations. So I'm going to write out this first one up here. W over 2 minus 3 over 4 equals 2W over 3 plus 2. Sorry, I usually do my 2's like that. Okay. Well, the first thing I'm going to try and do is I'm going to try to find my least common denominator, and I'll try to multiply everything by it to get rid of the fractions, because I personally just am not the biggest fan of fractions. So how I'm going to do that is I'm going to say, okay, this 4 on the bottom is a 2 times 2. And so my least common denominator, it needs at least 2 2's, because there's 2 in that one. That 2 is already covered. And we also need a 3. 2 times 2 times 3 is going to be 12. So I'm going to multiply everything times 12. So 12 times W over 2 minus 12 times 3 over 4 equals 12 times 2W over 3 plus 12 times 2. Teaming off this, 12 over 2, that is 12 divided by 2 is 6. So we get 6W minus 12 divided by 4 is 3. 3 times 3 is 9. So minus 9 equals 12 divided by 3 is 4. 4 times 2 is 8. W 12 times 2 is 24. Okay. Now I'm going to go ahead and I'm going to try to combine like terms. So I'll bring the 6w over. So we have negative 9 equals 2w plus 24. And then I'll bring the 24 to the other side. Subtract it by 24. We get negative 33 equals 2w. So that means that w equals negative 33 over 2. Okay. So going on to this next one, we're going to kind of do the same process. I'll work it on the left side now. So we have x plus 2 over 3 minus x minus 4 over 4 plus 1 equals x plus 1 over 6. So I'll take the bottoms of my fractions. I have 3, 4, and 6. 4 is 2 times 2. 6 is 2 times 3. And so my least common denominator is I need 1 3. I need 2 2s. And then this says I need a 2 and a 3, but I already have 1 2 and I already have 1 3. So I'm done. And that is, I believe, 12 again. So it's going to multiply everything I have times 12. So I'll have 12 times x plus 2 over 3 minus 12 times x minus 4 over 4 plus 12 times 1 plus 12 times x plus 1. This will become 4 times x plus 2 minus 12 over 4 is going to be 3 x minus 4 plus 12. And I put equals up here. That should have been, I put a minus, that should have been an equal sign. That's my bad. And that's over 6. Sorry, I just was jumping ahead. So over here you get 12 over 6. That's going to be 2 x plus 1. We'll go in and we'll distribute these. So we're at 4x plus 8. Make sure you distribute the minus sign with it. So minus 3x plus 12 equals 2x plus 2. Go and I'll combine like terms. So over here we're going to x. 12 plus 12 is 24 plus 8 is 32 equals 2x plus 2. I'll go now bring this x over. So I'll get 32 equals x plus 2. So that means x has to equal 30.
All right, so for problem 3c, we have 1 over y minus 1 is equal to 5y over y squared plus 3y minus 4 minus 3 over y plus 4. Now, figuring out our least common denominators, we realize that this factors to y minus 1 and y plus 4. I encourage you to go and solve that yourself if you can and verify. So then we'll have our least common denominators to choose from. We have a y minus 1 over here, and then a y minus 1 and y plus 4 from this denominator term, and then another y plus 4. So we know we're going to have a y minus 1 and a y plus 4, and since the other two have those in common, we know that our least common denominator is going to be y minus 1 times y plus 4. So if we do that operation, we can come over here and say this is y minus 1 times y plus 4, and then this is going to be y minus 1 times y plus 4, and then this is going to be y minus 1 times y plus 4. And like I said, I'm going to go ahead and erase this because we can rewrite this, right? We can write this as y minus 1 times y plus 4. So we know that the y minus 1's cancel on this side, leaving us with just a y plus 4. And then here we know that the y minus 1's cancel and the y plus 4's cancel, giving us a 5y. And here we know that the y plus 4's cancel, giving us a minus 3 times y minus 1. So then if we go ahead and solve for this, we get y plus 4 is equal to 5y minus 3y plus 3. And so then if we subtract the y on this side and combine like terms, and then subtract the 3 over here, then we get 1 is equal to y, or y is equal to 1. But if we go and plug this back into the equation, this part C, we get 1 over 1 minus 1 is equal to 5 times 1 over 1 squared plus 3 times 1 minus 4. I'll move this over times minus 3 over 1 plus 4, right? Which, as you can see in this left term, we have a 1 minus 1, which is a restricted value, making y a restricted value because we can't have 0 in the denominator, right? So actually, instead of y equals 1, there is no solution. All right, so for problem 4a, we are wanting to solve this interest equation for p. So if we have this p that's being multiplied by an r and a t, then we do the opposite operation to get rid of it on both sides, right? So if I write this out and I say I is equal to p times r times t, to get rid of it, we can just divide both sides by r times t. So then we get p is equal to I over RT. And I'll write that over here. All right, so for problem 4b, we're wanting to solve this t naught is equal to t1 plus t2 over 2 for t2. Okay, so if we rewrite this equation, I'll write it over here. We have t naught is equal to t1 plus t2 all over 2. All right, so if we're trying to get t2 by itself, we have this t1 and t2 that are both being divided by 2, right? So if it's being divided, we do the opposite operation and instead multiply by 2 on both sides. So that gets rid of that. And we'll have 2 t naught is equal to t1 plus t2. And we have this t1 that's being added to t2, right? So we can do the opposite operation and just subtract t1 on both sides. So then we're left with t2 is equal to 2 t naught minus t1. And I'll write that over here. We have t2 is equal to 2 t naught minus t1. All right, so for problem 5, we have Dexter's hybrid car gets 41 miles per gallon in the city and 36 miles per gallon on the highway. And so the amount of gas he uses is given by this equation, where C is city miles and H is highway miles. And it says if Dexter drove 288 miles on the highway and used 11 gallons of gas, how many city miles did he drive? And so I think starting off, it's important to realize what your units are and how they correspond to one another, right? And so if we define our variables here by this equation, we have A is equal to gallons, right? And then C is city miles, and H is highway miles. Highway miles. And so you see we're given values down here, and now we can look at these values and see how they correspond to the variables that we just defined. So we have if Dexter drove 288 miles on the highway, and so that's highway miles, right? So we know our H is going to be equal to 288 miles. and used 11 gallons of gas, how many city miles did he drive? And so 11 gallons, that's our A, right? So that's going to be 11. And we're looking for city miles. So the C is what we don't know. And so what we can do is we can plug these values that were given into the equation that we're given. And so if we plug these values in, we get 11. Oh, go back to my pen. We have 11 is equal to 1 over 41C plus 1 over 36 times 288. And so now we're just trying to get C by itself, right? So what we can do is we can subtract this 1 over 36 times 288 over. So that's going to be 11 minus 1 over 36 times 288. That's going to be equal to 1 over 41 times C. And which gives us, I'm going to come over to this right side, sorry. So that's going to be 3. If you put that in your calculator, 3 is equal to 1 over 41C. So then we can multiply 41 on both sides, right? To get rid of that 1 over 41. And then we'll be left with C is equal to 123 miles. And so we'll say Dexter drove 123 miles in the city. Alright, so for problem 6, it says a contractor must tile a rectangular kitchen that is 4 feet longer than it is wide, and the perimeter of the kitchen is 48 feet. We're supposed to find the dimensions of the kitchen. And so, with these kind of problems, it's always helpful to draw out and kind of visualize what they're saying, right? So we have this rectangular kitchen, and it says, so we have this width, W, right? And we have length, but it says the length is 4 feet longer than the width. So we can also rewrite this length as W plus 4, right? W plus 4. And we know that for a rectangle, the perimeter is 2L plus 2W. And that's going to equal 48 in this case. But we said that the length is equal to W plus 4, right? So if we substitute that in, we'll have 2 times W plus 4 plus 2W is equal to 48. And so now we can start simplifying this equation because now we only have one variable and we can solve for one variable with one equation. And so that's going to be, if we distribute that 2, it's going to be 2W plus 8 plus 2W equals 48. So then if we combine like terms, we add these two W's together and then we subtract by 8 on both sides. We get 4W is equal to 40, or W equals 10, which is perfect. And then to find our length, we can use that equation that we derived up here. So then we have our length is equal to W plus 4. That's going to be equal to 10 plus 4, or 14. So now we can come back up here and say, well, if I write this down, the kitchen, if I can spell, kitchen is 14 feet by 10 feet. All right, so for question 7, it says, Cassie bought a 10-year treasury note that paid the equivalent of 3.5% simple interest. She invested $4,000 more in a 15-year bond, earning 4.1% simple interest than she did in the treasury note. If the total amount of interest from these investments is $10,180, determine the amount of principal for each investment. Okay, so if we start out with the equations that we know, this is, okay, so we know that interest is equal to principal amount paid times the rate times the time, right? So for this treasury part, I'm going to go ahead and write that out, treasury. We have, I'm just going to call it I1 because it's our first interest. That's going to be equal to P1 times R1 times T1. And we have R1 and we have T1 too. So this is going to be our I1 is equal to 0.035 times our 10 years times our P1. Or if we simplify that, that's going to be I1 is equal to 0.35 times P1. All right, so that's our first one. Now, if we do our bond, it might be a little bit trickier. So I'm just going to call this I2. So then we know it's going to be P2 times R2 times T2. And so that's going to equal, let's see, so we have our time here, and we have our rate. So that's going to be P2 times 0.041 times our time of 15 years. And now it also gives us some very helpful information up here, right? It says she invested $4,000 more in this bond. So if we can write another equation for that, that's going to be P2 is going to be equal to our P1 plus 4,000, right? So then we can just substitute this in to our second interest equation. And so we're going to get I2 is equal to P1 plus 4,000 times 0.041 times 15. And that's going to simplify to, I'm going to write it right here, that's going to simplify to 0.615 P1 plus 2460. And now, if we continue on in this problem statement, it says the total amount of interest from these investments is $10,180. So the total amount of interest, that's going to be I1 plus I2 is equal to 10,180. And we have expressions for, I'm just going to write this down. We have expressions for I2 right here. And we have our expression for I1 right here. So then we can just combine that, right? So then we can have our I1 is 0.35 P1 plus 0.615 P1 plus 2460 is going to be equal to 10,180. So then we can combine our P terms. So that's going to be 0.965 P1, and we can subtract this 2460 over, right? 2460, and that's going to equal 777720. So then we can divide by our 0.965 to get P1 by itself, right? So then we'll have 7720 divided by 0.965. So then we're left with P1 is equal to, let's see here, $8,000. And now we said this was the principal amount for our treasury, right? So we'll say treasury amount, or treasury note, was $8,000. And we can come back to our P2 expression, right? Because we had P2 is equal to, and I'll circle this, P1 plus 4,000. So then we can just say our P2 is equal to 8,000 plus 4,000, which gives 12,000. So then we can say treasury note was 8,000 and bond was 12,000. And let me make this a little bit clearer, because that was not very good. 12,000, right? Alright, so for problem 8, it says, when Kevin commuted to work one morning, his average speed was 45 miles per hour. On his way home, he averaged only 30 miles per hour due to delays on the highway. So if the total time for the round trip, so there and back, was 50 minutes or 5/6 of an hour, determine the distance between his place of work and his home. Alright, so let's start with defining our equations. So we have, if we're given speed and distance, we can write that equation. We know that distance is equal to rate times time, right? Or if we rewrite this in terms of just time by itself, we can divide by rate. And so then we have time is equal to our distance divided by our rate, right? So it says the total time for the round trip was 50 minutes. So that's going to be our total time there and back. And that's going to be 5/6 of an hour. And we have to use the hour, right? We can't use the minutes because the units have to kind of coincide. And this speed is in miles per hour. It's not in miles per minute, so we can't use that 50 minutes. And so if we write this is going to be 5, 6, and it's going to be our speed there, our trip there, which is d1 over 45, plus our trip back, which is d2 over 30. Now, we know that the distance to his work from his house would be the same distance as the distance from his work to his house. So we can just say that this distance, this d1 and d2, we don't even need it. We can just say that it's just d, because it's the same distance, which is really nice for our equation. So now we can start by defining our common denominators, or at least common denominator, right? So we have 6, 45, and 30. Now we know that 6 can be broken down into 3 and 2. 45 can be broken down into 15 and 3. And that 15 can be broken down into 5 and 3, right? And then the 30 can be broken up into 10 and 3. And that 10 can be broken up into 5 and 2. So if we start off with our 6, we need a 3 and a 2. For our 45, we need a 5, and one of our 3's is covered right there, but then we still have this other 3 that we need. And so we're going to multiply it by another 3. And so then our 5 is covered from the 30, it's covered right there. Our 2 is covered over here, and then we got one of our 3's covered over there. So then if we multiply this all out, we got 3 times 2 times 5 times 3, that's going to be 90. So our least common denominator is going to be 90. And so then if we rewrite this equation, that's going to be, I'm going to bring this up here, so it's going to be 90 times 5 over 6 is equal to 90 times d over 45 plus 90 times d over 30. All right, so if we simplify this all down, this term will simplify to give us 75. This term, and I'll put the equal sign, this term will simplify down to give us 2d. And this term, and we'll have a plus, and then this term will simplify down to give us 3d. So then if we combine these like terms, the d's, we'll have 75 is equal to 5d, or d is equal to 15 miles. So the distance from Kevin's work to his house is 15 miles. We're gonna box that in.
Okay, now moving on to question number 9. Casper has a swimming pool in his backyard. Using water from one hose requires 3 hours to fill the pool. If a second hose is turned on, the pool can be filled in 1.2 hours. How long would it take for the second hose to fill the pool alone? So, sorry, I missed some erasings. What we're going to do is I'm going to kind of set this up that the work done by the first one, which is one pool. Oh, I'm highlighting. Sorry. Which is one pool in 3 hours, plus the amount done by the second, which is one pool, and we don't know the time, so we'll call it X. It's going to equal the total number of, the total work done per time. So 1 over 1.2. So on top, you put how much they've done, which in this case, each of them is one pool. On the bottom, you took how long it took them to do it. So to solve this, I'm going to find my least common denominator, which I'm just going to say is 3 times 1.2 times x. That's just all the bottoms multiplied together. We'll say it's 3.6x. And I'm going to go ahead and multiply everything by that. So we'll have 3.6x over 3, which 3 divided by 3.6, I believe, is going to be 1.2x, plus the x's will cancel when we multiply this times 3.6x, so 6x over x. So that's going to become 3.6. It's going to equal 3.6x over 1.2 will just become 3x. So I can go ahead and move the 1.2x over to combine my like terms. So 3.6 equals 1.8x. And I can divide both sides by 1.8. So we're going to get 2 equals x. So the second hose will take 2 hours to fill the pool on its own. So say 2 hours. Forgot the S. Okay, for number 10, it says on a police force there are 60 more males than female officers. If the ratio of males to female officers is 10 to 7, determine the number of male officers and the number of female officers on the force. So I'll set this up and I'll say there's 60 more males officers and female officers. So the number of male officers is 60 more than the female officers. And the ratio of males to females is 10 to 7. So using the second equation I wrote down here, I'm going to cross multiply. So we get 7m is equal to 10f. So since we know m is 60 plus f, we can go and substitute that in. So 7 times 60 plus f equals 10f. I'll distribute the 7. 7 times 60 is 420 plus 7f equals 10f. I'll subtract the 7f. So we get 3f on this side, and then I'll divide both sides by 3. We get 140 female officers, but we still need to find the number of male officers. Well, we know the number of males is 60 more than that. So 60 plus 140, oh my goodness, I can't even write. I got ahead of myself, equals 200, that's where the 2 is going to be from, which is the male officers. Okay, so 200 males, 140 female. Okay, looking at number 11. Write each of the following expressions in terms of I and simplify. Okay, so what is I keep going to highlighter, my bad. I is the square root of -1. So the idea is we're going to try to break these up just a little bit. So this one, square root of -144, same thing as square root of -1 times square root of 144. You can break up square roots. They're multiplied. You can break up into 2 different square roots that are multiplied. And we know square root of -1 is I. We know square root of 144 is 12. So we'll say this is, let's say that's 12, and this is I. So we'll say this is 12I, because we usually put I second. Going to the next one, we can kind of do the same thing. So negative, that negative's going to hang out front. I'll say this is -1 times square root of 75 to figure out the square, what comes out of the square root of 75, right? Because it's negative 1, that's I. 75 isn't a perfect square root, so how I do it is, I'm going to try to break it up into the numbers that multiply into 75. So for example, that is 25 and 3. Well, 25, I can take the square root of 25. Because that breaks down to 5 and 5. Because I have 2 of them, I can pull that out of the square root. I can pull a 5 out of the square root, but I'm left with the square root of 3. So this is going to become 5 square root of 3. Because it breaks down to 25 times 3. The square root of 25 is 5. So this is going to become, I'll put equals actually, the negative sign is still out front, 5 square root of 3, and then we put our I. Okay, on to this next one. One common mistake is when you have these negatives in the square root, you just multiply in. Before we do that, we got to take our i's out. So, really quick, I'm going to try and erase a little bit of the stuff we just had. Just give myself a little more space. Let me zoom in a little bit. Okay, so square root of 16 is going to become square root of negative 1 times square root of 16 times square root of negative 1 times square root of 9. Okay, so this is now going to become, we have an I times 4 times I times 3, which means we have 12I squared. I squared is going to be negative 1 because I is the square root of negative 1. So it's going to become negative 12. Okay, looking at this next one, again, this is going to be square root of negative 1 times square root of 32 times square root of negative 1 times square root of 8. So on 32, that can be broken up into 2 times 16. 16 is a square root. That's going to, because it's 4 and 4. So we can take one. We have 2 4s, so we can take one out. So we're going to get I times, this becomes 4 square root of 2. On 8, well, 8 is 4 and 2. Well, 4 can be broken down to 2 and 2. So we have 2 2s, so we'll take 1 2 out. So times I times 2 square root of 2. Okay, let's go and combine things. So we're going to get 8, and then square root of 2 times square root of 2. Well, so we have 2 squares of 2. Same thing as square root of 4, which is, those become 2. Other way you can think about it is square root of 2 squared times I squared. So that's going to become negative 16, because that's negative 1 times 2 times 8. It's negative 16. Next up, 12. Simplify the powers of I. So this is good to know your I cycle. I to the first, that's just I. That one's pretty straightforward. I squared, that's negative 1. We kind of talked about in the last part. I to the third, well, that's I squared times another I, so it's going to be negative I. And then I to the fourth is going to be 1, because that's negative 1 times negative 1. And then I to the fifth is going to be I again. So it cycles through. Every 4 it cycles. So the idea is we're going to try to break up this I to the 53 into I to some power of 4. And if the powers be a multiple of 4, because that just goes to 1 times whatever we're left over with, right? So is 53 divisible by 4? It's not. So what's the number below it? The closest one below it that is? Well, is 52 divisible by 4? Well, you can check on your calculator. It is. I believe it. Here, let me double check myself, actually. Sorry, yeah, I just double checked myself. 4 times 13 is 52. So, sorry about that. It's always good to check your work. This is going to be broken up to I. So 52 times I to the first, right? I still have a total of 53 I, so I haven't changed anything. But now this is I to the 52. Since 52 is a multiple of 4, that becomes just 1. So that becomes 1, that whole thing. So we're just left with I to the first, which is just the same thing as I. On this next one, first question is 84 divisible by 4? In this case it is. So It just becomes 1. And there's that. I believe in the next part, there'll be a couple more cases of these I powers and some other great questions. So tune in next time. Thanks.